Hello everyone, welcome to my channel. I am Christian Lupine, and in this series we are working out the previous year question papers of CMI M.Sc Data Science and ISI M.Sc QMS. In the earlier videos I have done the ISI M.Sc QMS 2015 paper. In the previous one I did the first 11 problems of the CMI M.Sc Data Science 2018 paper, and in this video I will work out the next 9 problems, question number 12 to question number 20 of the part A of that paper. So let's begin. Question number 12. In an entrance examination, multiple choice questions, each questions having 4 options and a single correct answer. Only 20% candidates think they know the answer to one difficult question, and only half of them know it correctly and the other half get it wrong. The remaining candidates pick one option out of the 4 randomly and tick the same. If a candidate has correctly answered the question, what is the probability that she knew the answer? So suppose total number of students are X. Suppose A is the event that one answers correctly and B is the event that one knew the right answer. So here given that 20% candidates think they know the answer and only half of them know it correctly. Number of students who knew the answer, that is of total students only 20%, and among them half of them knew it correctly. So this is X by 10. Then 80% students did not know the answer. So number of students did not know the answer was 4x by 5. Now as there was 4 options and among them one option is correct, so probability of choosing the correct option is 1 by 4. So among these 4x by 5 students, number of students who chose the correct option was 4x by 5 into 1 by 4, which is x by 5. So probability that the student knew the answer with respect to that is known that the answer was correct. So we have to find this probability of B given A. So which is probability of B intersection A divided by probability of A. Now we can write this as number of points at NB intersection A divided by number of A. Now number of B intersection A, that means number of students who knew the answer and they chose it correctly, that is we previously determined, that is x by 10. And NA, that means number of students who chose the option correctly, that means x by 10 plus number of students who did not know the answer but chose the correct option, x by 5. If we calculate this, then this will get 1 by 3. So the correct option is 1 by 3. Question number 13. There are n songs segregated into 3 playlists. Assume that each playlist has at least one song. The number of ways of choosing 3 songs consisting of one song from each playlist is. There are 3 playlists total. Suppose in the first playlist there are X songs, the second one there are Y songs, and total number of songs are N. So the other is N minus X minus Y. Right? It is given that each playlist has at least one song. So X, Y, these are greater than equal to 1. The number of ways of choosing 3 songs consisting of one song from each playlist. So if we denote this as F, we can choose the songs in ways X into Y into N minus X minus Y. One song from the first, one song from the second, and one song from the third playlist. We have to see what can be the value of F, or what can be the maximum value or minimum value of F. So this is a function with 2 independent variables, x and y. So first differentiate f with respect to x, then we'll get fx, that means del f del x, which is y into n minus x minus y minus y. If you take y common, it will be n minus, that is x, y minus n minus 2x minus y. Similarly fy, del f del y, x into n minus x minus y minus xy. We'll take x common, n minus x minus 2y. If we equate this with 0, fx equal to 0, fy equal to 0, then we will get y into n minus 2x minus y equal to 0 and x into n minus x minus 2y equal to 0. As earlier we have seen that x, y, these are greater than equal to 1, so y not equal to 0, x not equal to 0, so we can write n minus 2x minus y equal to 0, so 2x plus y equal to n, and similarly here x plus 2y equal to n. If we solve these two equations, we will get x equal to y equal to n by 3. Now we have to check at x equal to y equal to n by 3, does f possess the maximum value or minimum value, or what? We have to check that first. We are differentiating fx with respect to x again, then we will get fxx equal to minus 2y, which is less than 0, fyy, that is again minus 2x, that is also less than 0. Take fxy, that means differentiating fy with respect to x partially, then we will get n minus x minus 2y minus x, which is n minus 2x minus 2y. At this point, this is equal to fxy equal to n minus 2n by 3 minus 2n by 3, which is n minus 4n by 3, which is minus n by 3. Then we will evaluate fxx, fyy minus fxy whole square, which implies fxx at n by 3 is equal to minus 2n by 3 and fyy is equal to minus 2n by 3, which if we multiply, that will be 4n square by 9 minus fxy whole square, which is n square by 9, so it is 3n square by 9, which is greater than 0, and at the point x equal to y equal to n by 3, fxx and fyy, they are both less than 0, so you know that if fxx into fyy minus fxy whole square is greater than 0 some point xy, and also fxx less than 0, fyy less than 0 at that point, then we can tell that at xy point f is maximum. So here at x equal to y equal to n by 3, f is maximum and its value is n cube by 27. So this is the maximum value of f. So the correct option, which is option B, that the number of ways of choosing those songs is less than equal to n cube by 27 for all n, is the correct answer. Question number 14. Consider the following functions defined from the interval 0,1 to real numbers. Which of the function attain their maximum value in the interval 0,1? Okay, so we'll check one by one. Fx is 1 by x into 1 minus x. We can write this as x plus 1 minus x divided by x into 1 minus x, which implies 1 by 1 minus x plus 1 by x. Differentiate with respect to x, we will get f dash equal to 1 by 1 minus x whole square minus 1 by x square. If we equate it with equal to 0, we will get x square minus 1 minus x whole square divided by x square into 1 minus x whole square equal to 0. X plus 1 minus x into x minus 1 plus x equal to 0. This x will be cancelled out 1. This 2x minus 1 equal to 0, so x equal to half. F double dash equal to, if we differentiate this, f double dash will be equal to 2 by 1 minus x whole cube plus 2 by x cube. So this is greater than 0 at x equal to half. So at x equal to half, f is minimum. So option A is not correct. For option B, given gx equal to minus x minus 0.75 whole square, differentiate, will get g dash x equal to minus 2 into x minus 0.75. If you imply 0, it will get x equal to 0.75. G double dash, it is minus 2 less than 0. So at x equal to 0.75, g attains its maximum value and 0.75 lies in the interval 0,1, open interval 0,1. So option B is correct. For option C, ux equal to sine pi x by 2. Differentiate, we will get u dash x equal to cos pi x by 2 into pi by 2. If we equate this with 0, we will get pi x by 2 equal to pi by 2. So x equal to 1. So u double dash it is minus sin pi x by 2 into pi by 2 whole square. At x equal to 1, this is u double dash equal to minus pi by 2 whole square, which is less than 0. So u is maximum at x equal to 1, but this point 1 doesn't lie in the interval open interval 0 1. So option C is not correct also. For option D, Vx equal to x square plus 2x, v dash equal to 2x plus 2. If we equate 0, we will get x equal to minus 1. V double dash equal to 2 greater than 0. So at x equal to minus 1, v is maximum. So this is not the correct choice. So only correct option is option B. Question number 15. Farmer owns 50 papaya trees. Each tree produces 600 papayas in a year. For each additional tree planted, the output of each tree drops by 5 papayas. How many trees should be added to the existing orchard in order to maximize the total production? So suppose total production is P and X trees should be added to the existing orchard. Then the total number of papayas in a year will be, there is 50 papayas, so we will add X. For each tree, the output drops by 5. So existing production was 600 papayas each tree. It will be reduces 5 into X, because for planting each X trees, the output drops by 5 papayas for each trees along with the pre-existing trees. So this is the total output in a year. We have to maximize P, so we need the value of X for the maximum value of P. Differentiate P with respect to X. dp dx equal to 600 minus 5x minus 5 into 50 plus x. Equate this with 0, will get 10x equal to 350. So x is equal to 35. d2p dx2 will get minus 5 minus 5. So this is minus 10 less than 0. So for x equal to 35, P is maximum. So total number of trees to be added is 35. This is the answer. Question number 16. A and B are the numbers between 1 and 2. C and D are numbers between 3 and 4. Given U equal to A inverse, V equal to B inverse, W equal to C inverse, and X equal to D inverse. Then which of the following are true? Okay. So for A, B, C, D, these 4 numbers, we will apply AM. Arithmetic mean is greater than geometric mean. Strictly greater than, because these are not equal numbers. So if we apply this, we will get A plus B plus C plus D divided by 4 is greater than 4th root of ABCD. Similarly for UVWX, we will get U plus V plus W plus X divided by 4 greater than 4th root of UVWX. Multiply these two, will get A plus B plus C plus D into U plus V plus W plus X divided by 16 is greater than 4th root of ABCD into UVWX. Now U equal to A inverse, V equal to B inverse, W equal to 1 C inverse, and X equal to D inverse. So if we multiply ABC to UVWX, it will be equal to 1. So this is A plus B plus C plus D into U plus V plus W plus X greater than 60. So option A is correct. Similarly, apply AM greater than GM for A to the power 4, B to the power 4, C to the power 4, D to the power 4. We will get A to the power 4 plus B to the power 4 plus C to the power 4 plus D to the power 4 divided by 4 is greater than 4th root of A to the power 4, B to the power 4, C to the power 4, D to the power 4. This is equal to ABCD. Multiply this, A to the power 4, B to the power 4, C to the power 4 plus D to the power 4 is greater than, multiply 4 here, we will get 4 ABCD. So this is true, but option B is opposite of that. So option B is wrong. We know that 1 less than equal to A less than equal to 2. So from here we can get 1 less than equal to A square less than 4. Similarly for B, 1 less than B square less than 4. If we add this, we will get 2 less than A square plus B square less than 8. With this, multiply this condition. Then we will get 2 less than A square plus B square less than 16. Similarly, B has the same condition, so that multiply that condition, then we'll get 2 less than AB, A square plus B square less than 30. Similarly, 3 less than C less than 4. So we'll get 9 less than C square less than 16, 9 less than D square less than 16. Add these two, get 18 less than C square plus D square less than 32. Multiply this condition, we'll get 54 C less than C into C square plus D square less than 128. For D, multiply this, we'll get 162 less than CD, C square plus D square less than 5112. This term lies between 2 and 32, and this term lies between 162 and 5112. So obviously AB, A square plus B square is less than CD, C square plus D square. Take this AB this side and take CD this side. So we'll get A square plus B square divided by CD is less than C square plus D square divided by AB. W equal to 1 by C, so C is equal to 1 by W, and for that this is applicable each way. So we can write this as A square plus B square into WX and C square plus D square into UV. So option C is also correct. For option D, apply AM greater than GM for A cube, B cube, C cube. Then we'll get A cube plus B cube plus C cube by 3 is greater than cube root of A cube, B cube, C cube. Then A cube plus B cube plus C cube is greater than 3ABC. D is between 3 and 4, so that is a positive number, and that is greater than 1. So if we multiply D with A cube plus B cube plus C cube, it will increase the number from A cube plus B cube plus C cube. Then we will get D into A cube plus C cube is definitely greater than 3ABC. So option 4 is wrong. So correct options are option A and option C. Question number 17. There is a code fragment given. Start and end are integer values and square x is a function that returns true if x is a perfect square and false otherwise. So there is a code given here. At the end of the for loop, which of the following are correct statements about the relationship between I, J and K? So to do this problem easily, we will take, suppose A is a perfect square number, and we will run this loop for 3 numbers A plus 1, A plus 2. As A is perfect square, A plus 1 and A plus 2 are not perfect square. So we will run this loop for these 3 integers. So at first I equal to 0, J equal to 0, K equal to 0. So for A means start here means the first number, which is A. If square M is equal to true, yes, A is a perfect square and it will return true, then this part will be executed. Then the value of I will be I plus M cross M into M. I value is 0 plus M into M. M means here A into A, which implies A square. And the value of K will be K previous value is 0 plus M into M, A into A, which is A square. For the next value, A plus 1, this is for M equal to A here. For M equal to A plus 1, if square M equal to true, no, M is, then A plus 1 is not a perfect square, then this part will be executed. So J will be J is 0 plus M into 2, M means A plus 1 into 2, so it will be 2A plus 1. And K will be K previous value is A square plus M into 2, M means A plus 1 into 2, which is A square plus 2A plus 1. Now for next, M equal to A plus 2. Then again A plus 2 is not a square, so this part will be executed. J equal to J, previous value of J is 2 into A plus 1 plus A plus 2 into 2, which implies 4A plus 6. And K is K plus M into 2. K previous value is A square plus 2 into A plus 1 plus 2 into A plus 2. Then this implies A square plus 4A plus 6. Now we will check which of the following are correct statements. So first check for this, if end minus start is even. Now here end is, for our example, end is a plus 2 and start is a. So n minus start is even. Yes, that is even. So we will check this. K equal to I into I plus j into 2. K equal to I into I plus j into 2. Okay, we will check this. Now I into I means here I value is a square, so a to the power 4 plus j into 2. 2 into this part, final value of j, 4a plus 6. Final value of k is a square plus 4a plus 6, and this is not equal to this. So option A is wrong. So there is another option with end minus start is even. We will check this for it. J equal to k minus I. J equal to, it is written k minus I. Okay, value of k is a square plus 4a plus 6 minus I is a square. So value of j is 4a plus 6. Yes, final value of j is 4a plus 6. So this option C is correct. Now we'll check end minus start is odd. To check this condition, if end minus start is even, we are taking only these two, m equal to a and m equal to a plus 1. The first is given as k equal to I into I plus j if n minus star is odd. We are checking only for these two. Then I into I is a square, so I into I is a to the power 4 plus j. Here value of j is 2 into a plus 1. So we will write it 2 into a plus 1. But here value of k is a square plus 2 into a plus 1. So again option B is wrong. We'll check for option D. It is written I equal to k minus j. The value of k is a square plus 2 into a plus 1 minus value of j here is 2 into a plus 1. So we'll write it 2 into a plus 1, and that is equal to a square. Yes, I value is a square here. So this option is also correct. So correct option for this question number 17 is option C and option D. Question number 18. The following definition of the function f(OO) is given. We have to find what does this means. What does this function returns? A quotient B. This is the sign of quotient. That means we get the integer part of A divided B. So here is an example given. 7 quotient 3 is 2. There is a function given. Function is x equal to 0 while n greater than equal to 1. X is increasing by 1 and n value is assigned as n quotient D. After the while loop, we are returning the value of x. Okay, so first x equal to 0 and n value is first 1037. N value is greater than 1 for greater than equal to 1 for first case. Then x value is equal to 0 plus 1 and n value is 1037 quotient 2, which implies 518. Next, n value is 518, which is greater than equal to 1. So x value is increasing by 1, so it is being 2, and n equal to n quotient D, n quotient 2 here, D is equal to 2 here, so this will be 259. Similarly, for the next step, it will be x equal to 3 and n value will be changed by 129. Next, 129 is greater than equal to 1, so x will be 4 and n will be 64. 64 is greater than equal to 1, so x will be increased by 1, 5, n will be 32. Next, 32 is greater than equal to 1, x will be increased by 1, n will be 16. 16 is greater than equal to 1, so x will be increased by 1, will be 7, n will be equal to 8. Again 8 is greater than equal to 1, so x will be increased by 1, 8. N will be 8 quotient 2, which is 4. Again 4 is greater than equal to 1, then x will be increased by 1, n will be equal to 2. 4 quotient 2 is 2. Again x 2 is greater than equal to 1, so x will be increased by 1, 10. n 2 quotient 2, which is equal to 1. Now 1 is greater than equal to 1. There is a equality condition, so that is true. So again x will be increased by 1, x equal to 11. N will be 1 quotient 2, that is equal to 0. Now 0 is not greater than equal to 1. So the loop here breaks and it is returning the value of x, which is x equal to 11. So this function returns the value 11. Question number 19. A very special island is inhabited only by knights and knaves. Knights always tell the truth. Knaves always lie. To meet three inhabitants, Ramesh, Bharat and Menaka. Ramesh claims Bharat is a knave. Bharat says Menaka and I are both knights or both knaves. Menaka claims that Bharat is a knave. Which of the following are correct? So suppose option A is correct. Let A is correct. Then Bharat is a knave. Then Bharat always tells lie. So here Bharat says Menka and I are both knights or both knaves. That means if this is a lie, then Menka and Bharat are different ones. That means if Bharat is a knave, then Menka is a knight, and if Bharat is a knight, Menka is a knave. So as Bharat is a knave, then according to the condition, Menka is a knight. Now as Menka is a knight, Menka here says that Bharat is a knave, which is right, and as knights always tell the truth, then as Menka claims here Bharat is a knave, this is also true, and here the condition is Bharat is a knave, so this is true, and again there all another condition, Ramesh claims Bharat is a knave, which is here correct. So if option A is correct, then Ramesh is also a knight, as Ramesh is telling the truth. Option A is correct, and then also exactly two of them are knight. So option D is also correct. Here option B is also correct, at Ramesh is a knight here. So for correct options are option A, B and D. Question number 20. There are 7 switches on a switchboard, some of which on, some of which are off. In one move, you pick any 2 switches and toggle each of them. If the switch you pick is currently off, then you turn it on, and if it is on, you turn it off. Your aim is to execute a sequence of moves and turn all 7 switches on. For which of the following initial configurations is this possible? To pick 2 switches and toggle them, we must need even number of switches off to turn it on. We are taking as odd number, so for our easiness we are taking 3 switches. To show you, I am taking number of off switches. 3 switches are off. Then pick any 2, and if you toggle them, then that will be off. So only one switch is off and others are on. You have to pick 2 switches at a time. So if you pick this switch and on switch, if you toggle them, then this switch will be off, but another on switch will be off. Again this thing continues, and this is a circle. So to perform that operation here, the given operation which we have to perform, we must need even number of switches off. So only the first option there are 2 switches off, and in the fourth option there are 4 switches off, and other than that option B there are 3 switches off, and here 5 switches are off. So only even number of switches are off in option A and C. So the correct option is option A and option C. So we have completed all the 20 questions of the part A of the CMI M.Sc Data Science 2018 paper. I hope it was helpful. So in the next video we will work down the next 10 problems of the part B, the subjective part. So stay tuned for that. In the earlier videos I have made the ISI M.Sc 2015 paper, and the first part of these videos are also there where I worked out the first 11 questions of this paper. So if you haven't checked that yet, please check it out. The link will be given in the iCard or in the description box. Please press the like button if you like this. Share this among friends who are appearing for this exam, these sessions, and subscribe to the channel if you have not subscribed it, and press the bell icon to get all notifications whenever I upload a new video. Okay, thank you for watching. See you in the next one. Till then, goodbye.